The birthday problem or paradox provides insight to how random numbers might duplicate based on precision and sample size of the random values generated. For instance, if we generate a single-digit value, there are 10 permutations, 0 through 9. Naturally, as sample size increases, the probability of matching pair of values increases. For example, 100 generated random numbers, n, is more likely to produce a match than 5 samples. Let's try this on the birthday calculator to the right. So for n, we'll put in 10, and for sample size, we'll put in 5. And we'll watch PB. Shift F9, and it says we have a 65% probability of a matching number. Now, let's change this to 100 samples. What do you think the answer is going to be? The probability is 1, so we'll certainly get a duplicate value. As the precision of the random values increases, let's say to 10 to the 15, which will equal 10 raised to the 15, and we take 10,000 samples, which is what we typically use when we're making PDFs. Shift F9, and we can see that the probability of generating a duplicate value is about 5e to the minus 8, or 5 out of 100 million. And this generally explains why a mode value is not found using Excel's built-in mode functions. So the formulas used in this exercise arise from the birthday problem. The birthday problem asks how many people need to be in a room for the probability of 2 or more people to have the same birthday exceed 50%, where n equals the number of days in the year, and k is the number of people that need to be in the room, or 23 people, for the probability to exceed 50%. C in the formula is always 2. This analysis compares every potential pair of values. So let's do this. We'll put in 365 for the number of days in the year, and we'll put 23 people, which was found empirically, and Shift F9, and we can see that the probability of at least 2 repetitions is more than 50%. I hope you found this video useful. Thanks for listening. Like and subscribe.